Okay, good morning everyone. I think we can start na, no? Mukhang konti na lang papasok. Ay, sorry. Hello, hello. Ayan pala, hindi ko na unmute yung sarili ko. Okay, good morning everyone. I think we can start now, no? And I'll be recording this session para dun sa mga hindi makakapasok today. Okay? Narinig ba ako? Okay naman?
Yes, sir.
Okay, thank you for the confirmation. Okay, so gagawin natin ngayon is we'll be answering or I'll be guiding you doon sa worksheet number 6 natin, no? So, I'll be using exclusively yung MS Mathematics natin, no? Para makita nyo yung power niya or yung effectiveness ng MS Math na software, no? Okay? So, let's start with the first problem. So, let me just pull out ano, no? Okay. Worksheet number 6. Saglit lang class Hanapin ko lang yung PDF file. Although I believe you have a copy of this, no? Okay. Nakikita nyo? So let me just extend the screen, no? So ito yung let's run through this. I think this will be a short lesson lang, no? Kasi medyo relatively madali lang naman yung problems. We'd start with yung first one, which is yung problem number 1. So meron daw tayong drawing na process, no? So it's 15%, it starts off as a 15% cold work wire. Tapos kailangan daw natin siya i-draw from a 16.25 millimeter diameter na steel wire. And by the way, class, whenever you have something like this, no, itong mga ganito, if hindi specified, kunwari, ang sinabi lang is 16.25 millimeter steel wire, the convention is usually uh, this is a diameter na parameter, no? Pag sinabing 16.25 wire or 16.25 millimeter na rod, it usually means the diameter if hindi siya given. Okay? So dito binigay naman, sabi na diameter yung 16.25. Then the die has an angle of 30 degrees and the coefficient of friction is around 0.08. So the flow stress, while the process is being done, no, is around 165 megapascals, and we are to determine the number 1 diameter of the product, letter B the drawing pressure, and lastly the drawing load. Okay, so we start off with the easier one muna, no? So I'll pull out my MS Math na software. Okay, so etong sorry, ano yung okay. So, ito yung MS Math natin. Tapos we start with letter A muna, no? So, it's fairly simple, no? Kasi we have a formula para makuha yung strain. Or, di ba, our strain is just equal to, nakikita nyo naman, guys, no? Yung nakasulat sa board. Dun sa ano ko, dito sa work area. I hope. Okay, thank you, Ivana and Rebo. Okay, so we have E is equal to 1 minus, because this is a ano, no, usually when we talk about strains, lalo na pagka ano, no, circular yung cross section, we usually take the strain not in the longitudinal direction but in the radial direction, no? So etong strain na to, we get the strain as a change in cross sectional area. So we can do it as 1 minus AF over A naught, which is just the same as ano, no, this is just saying na this is also the same as saying A naught minus AF over A naught. Tama? This is the same form, no? Kapag ni-reduce na lang siya. So, if you do longitudinal strain, it's L naught minus LF over L naught. Tama? Oh no, sorry. Pag longitudinal strain kasi usually kasi we want it to be a positive value, therefore usually kasi pagka longitudinal strain, it's lalo na pag tensile yung direction, the final diameter is greater than the initial diameter, kaya LF siya minus L naught. Pero since dito, this is a we are drawing it, therefore lumiliit yung ano natin, yung yung cross-sectional area. So, ang para makakuha tayo ng positive strain, it's A naught minus AF over A naught. Okay? So, if we simplify this, we should get 1 minus AF over A naught. Okay? Okay, so that's the formula. And one thing to note, no, itong AF over A naught, this is also a unique na value. This is known as your reduction ratio R, where reduction ratio R is just the final diameter over the initial diameter. Okay, and I think you've seen this in the modules, no? Yung reduction ratio. So there are two measures of ano no, yung reduction sa ano natin sa when it comes to drawing and extrusion. It's either you measure it as reduction strain, pwede ring reduction ratio. If it's reduction strain, then it's 1 minus reduction ratio, while reduction ratio is just AF over A naught. Okay, so let's try to solve it. So given yung strain, sabi daw um it's 15% cold work. So if it's 15% cold work, then the amount of strain should be 0.15. Tama? And we have our initial diameter, which is um our initial is 16.25, and this is tatanggalin na natin yung pi over 4, no? So we can just diretso ganyan lang, 16.25, and therefore ito baguhin na natin siya to just x squared, no? Where our x here is the final diameter. Okay? So kung meron tayong ganito, it's as simple as just pressing enter, no? And your MS Math will solve it, solve the equation on its own, no? So you'll notice na sa MS Math, it has something that looks like this, ito. So siya na nag-input dito, no? Yung syntax na to. Pero there are cases wherein you have to input the syntax yourselves, no? So naalala niyo yung nag-system of equations tayo, no? Instead of using solve, ang ginamit natin is nsolve. So, pero in general, pag may sinulat kayong formula, so kung may sinulat kayo isang equation, tapos meron lang siyang isang unknown, MS Math is smart enough to know na you are trying to solve for that particular variable. So in this case, kasi ang sinulat lang natin, I mean, is 0.15 is equal to 1 minus x squared over 16.25. Then smart enough si MS Math to detect na, okay, we are trying to look for x squared. But the full syntax is this, no? This is solve this equation and find this variable. Okay? So we have two equations, which is just the positive and negative na ano no na since this is a squared na equation. So yung positive and negative siya, and we obviously we just want to get the positive na value, no? So we have our final diameter should be 14.98. Okay, so when we draw this wire to produce the 15% cold work, from 16.25 magiging 14.98 siya. Okay? So that's the first part. Now let's go with yung second part natin, which is, and i-expand ko lang to, no? Oop. Okay, so next natin is yung part B, which is the drawing pressure. So for extrusion and drawing, we always calculate yung capital B natin, no? Which is just B is equal to yung mu cot alpha. Parang ganyan. So that's B cotangent of the diangle alpha. Okay? So, and this diangle should be the half diangle, no? So if you remember dun sa ano, usually kasi we say when we talk about the diangle, and let me just get I don't know, buksan ko lang yung drawing board ko, class. Okay. I'll just wait for it to load. Okay. Pero sige, while this is loading, no, may questions pa so far? Ano, madali pa naman, no? And I believe all of you got this value, no? Dapat pala hindi ko pinapakita yung final answer, no? Pero anyway, okay lang. So, may questions ba so far? Nakakasunod pa naman, no? I-chat nyo na lang kung nakakasunod pa kahit okay lang or K. K. K pa po. Thank you, Ricken. Okay, so, eto, uh, let me just, okay, so, to illustrate no kung what I mean by the diangle is, something that looks like this. So, if you have, kung ito yung opening ng, oh, let me convert this. Select. Okay. So, kung meron tayong, kunwari, ganito, this is our, and increase ko lang yung ano. So, yan. Kunwari yan yung ano natin, yung opening. This is our die. And we are extruding metal from this portion. Tapos i-extrude natin papunta dyan. So, the direction of the extrusion or the drawing process is, and for this particular case, it's drawing, no? Is going in this direction. Okay? So, when we say diangle, we mean when it's the full diangle, ito yung sinasabi natin. So, from here to here, and ano ko lang. Yan. Etong angle na to, this is our full na diangle. So, we'll just say theta, no? Okay? So, yun yung full diangle natin. But, when we calculate for B mu cot alpha, alpha is just actually half the diangle, no? So, we call it as the half diangle. So, if we take the center point, then alpha is just half of theta. Okay, so theta over 2. So this is important, class, no? Remember always na pagka kinocompute natin yung the constant capital B, we are using the half diangle as opposed to the full diangle. Okay? So sabi kasi dito, so if that's the case, no? So for this particular problem, ang ano natin, we have yung mu natin is given, no, this is 0.08. Okay? Tapos we are getting the cotangent, no? And let me just find cotangent. Trigonometry, cotangent. Yeah. So that's 0.08. Oh, 0.08 times the cotangent of half of the diangle, no? Which is since 30 degrees ang full diangle natin, then half diangle is 15 degrees. Okay? So, I'm assuming na and be careful, class, no, kasi baka naka-radian siya, pero I think naka-degrees naman. So, if you look at the top, sige, show ko lang yung full view na, no. General. So, pag tinignan nyo yung sa taas, merong settings dito. So make sure nyo naka-degree siya kasi pag naka-radian siya, similar dun sa calculators natin, kung naka-radian siya, mag-iiba yung magiging results niya. Okay, so make sure na naka-degrees dito sa taas. Okay, so naka-degree siya. So, so for this case, we can do 0.08 is equal to cot 15, and this is our constant b. So tatanggalin ko lang to. So we have 0.298 or 0.299. So this is our b, and we can input it in our equation, and it's a straightforward lang na na calculation. So it's we have our yung flow stress, which is 165. Tama ba? Let me double check that. No? Okay, so it's 165 times b. It's 1 plus b over b. So this becomes 1 plus 0.299 divided by 0.299. Ma? Then we multiply this by if you remember the equation, it's 1 minus yung AF. So remember class, no? Pagka ito yung tricky part dito sa equation na to. So it's AF raised to the power of B. Itong buong to. AF over A naught. I-raise natin to the power of B. So ganyan. Ganyan dapat siya. Tapos remember class na ito yung formula ng drawing pressure. So just remember na kung drawing load, kung extrusion pressure to, magbabaliktad yung AF and A naught. Okay? So siguro this is where it gets confusing, no? Kasi same lang yung equation ng drawing and extrusion. The only difference is nagbabaliktad yung yung final and initial. Kasi take note na when we're doing drawing, yung kung saan tayo nag-analyze. So if I kasi again, take note na itong mga pressures na to, or itong na to, yung mga formula na to was taken from slab analysis, no? So similar sa doon sa ginawa natin for rolling and forging. And take note na pagka extrusion yung ginawa natin, if extrusion yung ginawa natin, we are doing the slab analysis on this end. Okay? So, since nasa final end tayo, ito lang yung kailangan yung tandaan class, no? Pag drawing siya, since we are doing it at the final dimension, then lahat ng nasa taas na values or yung numerator values is final dimensions. Okay? So, it's final over initial. Tapos, pag naman, extrusion yung ginawa natin, we are actually doing slab analysis dito sa portion na to. So that's why doon sa extrusion, actually initial values yung nasa numerator, no? So you'll have something like A naught over AF multiplied by, if you're computing for the forging or the extrusion force, i-multiply nyo siya by the initial na dimensions or initial area. Tapos opposite, pag drawing, you are multiplying it by the final area. Okay? So, balik tayo dun sa natin. So, again, ito siya. So, this is the forging, the drawing pressure. Tapos, kung gusto natin makuha yung drawing load or the drawing force, then you will just multiply this by the final dimensions. So, A final. Parang ganyan. Okay? So, ito lang yung tricky part class, no? Ito yung nagbabago. And if since this is pagka usually pagka circular yung cross section natin, yung of course you need to compute for yung width over height niya. Pero usually pagka circular siya or square yung cross-section area, then it's homogeneous deformation. Therefore, pag homogeneous deformation, hindi na tayo mag-multiply ng um, hindi na tayo magmumultiply ng ano, yung correction factor natin, which is yung 1.155 or yung 2 over square root of 3. So ito, diniretso na natin kasi this is a homogeneous deformation. No? Tapos ito, pwede natin siyang further simplify pa, no? Since this is this area here can be simplified as yung final diameter over initial diameter, tapos lalagyan mo lang ng 2 dito. Tama? Kasi magka-cancel out lang naman yung pi over 4. Okay, so if you evaluate this, hopefully you should get the final answer. And I'll not show anymore kung ano yung final answer, class, no? Pero it's fairly straightforward. Yung pinakamahirap na part lang siguro nito is identifying kung ano kung full diangle ba siya or half diangle. Tapos identifying kung alin yung nasa taas, no? Kung yung final ba or yung initial. And again, just try to look at the yung visual na ano dito, na A dito is just looking at how you are analyzing you are doing the slab analysis, I mean. So pagka drawing, you are doing it at the extruded end or dun sa past the die na end, dito sa side na to. You are doing it in this side, therefore final dimensions. Pero pagka you're doing extrusion, you are doing it at the initial end or dito sa part before it enters the die, no? So that's why again, as I mentioned earlier, that's why initial yung dimensions pagka extrusion siya. Okay? So, malinaw ba yun? So, etong problem 1, more of ano lang siya, no? Straightforward na plug and play. I hope nakasunod lahat. Before I proceed to problem 2, meron bang questions? Are there muddy points na kailangan kong i-clarify? So, I'll give you a few moments, no, para pag-isipan siya. And kung wala namang malabo, maybe you can type na or you can chat or mic in na we can proceed. Okay, thank you. Okay, thank you. Thank you for the feedback, guys. Okay, so let's proceed to problem number 2. Problem number 2. Let's go with Okay, so this is problem number 2. Meron daw tayong 50 by 50 by 300 millimeter millimeter cube bar of aluminum alloy that is to be hot extruded at a rate of 30 millimeters per second. So the cross-sectional area of the product must be 35% smaller without changing the initial width of 50 millimeters. So the coefficient of friction is 0.35. And given that the flow stress is around 105 megapascals, we are to determine the following, no? Thickness of the product, the extrusion load using a die angle of 65. And this is a common feature sa no, class, no? Sa extrusion versus drawing. Pag drawing, usually sobrang tapered ng angle niya, yung die angle. So, para usually kasi our metals are and I think you've already know this from previous na ano no na FISMET subjects that metals are more likely or are stronger in compression than they are in tension. That's why sa pag-drawing process, usually kailangan tapered yung diangle mo para hindi ka mag-introduce ng large enough stresses, no? Pero pag extrusion, since more compression siya than actual tension kasi you're working on the initial end, no? So kaya mo kahit hindi ganun ka-tapered yung diangle mo. So if you look at this is 65 degrees kahit hindi siya ganun ka-tapered. It can still produce the amount of or the desired deformation dun sa process na yun. Okay? So again, this is less tapered kasi I'll just illustrate class now baka hindi malinaw yung point ko. Kasi pagka mas malaki yung theta mo, mas wide yung opening, no? So if you have a larger theta, oh, so kung meron ka larger theta, mas malaki yung opening mo. So in this sense, hindi tapered yung design niya, no? Kung paano siya papasok from this initial tapos papasok siya dito. When you have something like drawing, usually gusto natin low yung diangle, no? Pag ganyan siya. So it's more tapered siya. Yung entry niya, kumbaga. So the metal can plastically deform without actually breaking, no? Kasi when you have something like this, you have what we call as, and I think nasa module din to, no? Pero just to recap, you have what we call as redundant load, no? So redundant load is the load needed para if your crystals are going this way, you need to reorient the crystals this way before it can actually flow out, no? Pagka extrusion. So pagka nandito, pagka lower yung diangle mo, mas lower yung taper, so yung amount of redundant load na kailangan is actually less, no? Kasi less yung reorientation ng crystals na kailangan mo para makapasok siya dun sa die opening natin. Okay? So that's enough about that. Like tayo sa problem. So again, the extrusion load using a large diangle of 65 degrees. Tapos the amount, and we are to calculate the amount of power expended on the extrusion process. Okay? So, punta tayo sa MS Math natin. Okay? So the first one is, let's determine the thickness of the product muna, yung magiging final thickness niya. So sabi daw, hindi daw kailangan natin i-maintain yung 50 millimeter width, no? So kung i-maintain natin yung 50 millimeter width, tapos alam natin na i-reduce natin yung wait, sorry. Let me just ang sabi daw is kailangan yung cross-sectional area is 35% smaller without changing the width. Then, obviously, yung length yung magbabago, no? So, ang gagawin natin is, hindi tayo magko-constancy of volume actually na formula dito, no? Ang gagawin lang natin is fairly straightforward, no? Sasabihin natin na yung final dimensions niya should be 35% smaller, so that's 65% lang of the original, and the original is 50 times 50. Tama? This is the original na diameter. Tapos, kailangan daw yung final diameter, final width should not be changed. So, 50 pa rin siya multiplied by yung final height niya. Parang ganyan. Okay? So, if I just, I'll just use h, no, para isang variable lang siya. So, if I press enter, I should get 32.5. Okay? So, etong 32.5 na to, this is the final height. Given na hindi nagbago yung width niya. And what can you observe about this process class? With that alone lang, no? Sabi na hindi nagbago yung width, tas ang height lang nagbago. Are there or meron ba kayong mako-conclude na sa type of process na to in terms of yung correction factor? Plane strain. So I heard someone say plane strain. Ikaw ba yun, Rebo? I'm not sure. Si Riquel ba yun? Si Rebo. So this is kahit ano, no, hindi tayo nag-check ng width over byte. We know that this is plane strain, no? Kasi one direction did not change, no? So meaning ang plane that we are working on here is the width and length plane. So doon lang siya nagbago. So the strain only occurs in those two directions. Okay? So this is plane strain, and when we compute for yung extrusion load, Obviously, lalabas na yung correction factor natin kasi we have established na plane strain to. Okay? So, to solve for the extrusion load, first, i-compute muna natin yung B mu cot alpha, no? So, again, yung mu cot alpha natin is, mu is given, no? Sabi, 0.35. Let me just check kung tama nga. So, it's 0.35. So, coefficient of friction is 0.35. And we multiply it by the cotangent. Okay? Multiply it by the cotangent ng we have a full diangle of 65. Therefore, yung half diangle natin is 32.5. So this is mu cot alpha and we should get 0.5549. Yan yung magiging ano natin. B. So if we compute it, so we can do 1.155 or you can do 2 over square root of 3, no? Multiplied by the what is the extrusion load natin? Sabi daw flow stress is excuse me class. Flow stress is 105. So that's 105 multiplied by yung 1 plus B over B. So I'll just i-diretso ko na class, no? 549 over 0.549. Usually kasi yung B mu cot yung B natin is a fraction, no? Or is less than 1. So, usually pagka na-solve nyo na siya, it's dun sa numerator part, it always becomes 1 point whatever B you have. So, kaya 1.549 over 0.549 multiplied by, so yung formula natin 1 minus, and this is extrusion, no? So, because it's extrusion, yung sabi natin kanina, kung extrusion, our slab analysis is working on the initial end ng workpiece natin. So kaya yung A natin sa initial will be A naught. Doon sa numerator, I mean. So notice this is different from yung kanina, no? Which yung kanina, if you remember, it was AF over A naught. Okay? So this time, it's A naught over AF. And etong A naught over AF is just equal to um, multiplied, raised to the power of B pa to, no? Tama? It's raised to the power of B. Okay? Tapos kung gusto natin makuha yung yung kung extrusion load yung kino-compute natin, this is still pressure, no? So extrusion load, multiply pa natin siya by wait, tayo na mag-type. Ayan. Multiply pa natin to by the the initial na na dimensions. Again, pagka extrusion, initial dimensions parati siya. So, initial dimensions yung numerator, initial dimensions yung i-multiply nyo para makuha yung load. Okay? So, ito actually class, pwede nyo i-compute, no? So, etong A naught na to, pwede actually natin i-simplify kasi sabi natin hindi nagbago yung width. So, actually, yung 50 kung length, yung width times height niya, tapos dito sa baba is width times height ulit. Magka-cancel actually yung width, no? Tama? So, kung magka-cancel yung width, magiging H naught over HF lang actually ito. So, kung ano yung na-compute natin dito, yung 32.5. So, it's 50 yung initial over 32.5. So, pwede ma-simplify actually natin, no? So, we can do, this becomes now 50 over 32.5. Okay? Tapos, multiply natin sa initial, which is, you remember, 50 times 50 lang siya. Okay? Then, our B is a 0.549 siya. 549. Okay? So, if we evaluate this, then you should get the final answer, no? Yung extrusion pressure. Now, to get the extrusion power is just, it's measured in watts. And watts is just force times velocity. Tama? So kasi ang ang unit of power is it's joules per second, no? And yung joules kasi natin is just Newton meter. Tama ba? Yes, joules is Newton meter. Let me double check. Yes, it's Newton meter, no? So, if we want to get, if we have kilonewtons, if we have, if you have the initial power, if you have already computed the extrusion na load, then what we actually just need to do is, kailangan lang natin i-compute kung gaano kabilis niya ina-act upon yung load na yon. Okay? And that value actually is yung ano natin, yung nandito sa ano, no? Ay, hindi sinabi. Wait. Sabi pala dito. Ang sabi dito na it is extruded at a rate of 30 millimeters per second. So yun yung rate kung saan ina-apply niya yung um yung yung extrusion load na yon. So if we multiply this is in kilonewtons, ano? So if we solve this, this will be in kilonewtons. Pag multiply natin by 30, it's at a rate of 30 millimeters per second. This becomes kilowatts, no? So sorry, this becomes watts pala kasi naka mm siya tapos naka kilo to. So ang final answer dito will be in watts, no? Tama? Tapos pwede nyo i-convert into kilowatts. Okay? So, di ko na ipapakita yung final answer. I think you can solve this on your own, ano. Pero before we proceed to part yung last problem natin, meron ba tayong questions regarding the problem? Sige, may papakita lang ako sa inyo class, no, kasi this is interesting, no. If I actually I'll evaluate this part, no. Oop, ano nangyari? 1.55. Ay, nag-X pala ako. Ah, ah, kasi ang ginamit ko dito class is X, no? So, na-detect niya as a variable. So, dapat ang ginamit ko is multiply. Yung multiply is yung asterisk symbol. So, if you do shift 8, yun yung asterisk. So, 50 times 50. So, mali etong dito part class, no? Kasi ginawa ko X, kaya akala niya variable yung 50. So, ito, I'll re-evaluate it. I'll get something like this. And this is actually negative 228.24 kilonewtons, no? So notice class na nag-negative siya, no? So this is just because of the way we did the slab analysis class, no? Kasi since we are looking at it from the opposite end, parang nagbago yung direction niya relative doon sa slab analysis natin. Okay, so relative doon sa positive x direction natin when we did slab analysis, parang negative to. So that's why usually opposite yung makukuha niya, no? Pagka drawing yung ginamit nyo, positive yung lumalabas na value, tapos pag extrusion, negative yung lumalabas na value. Okay? So again, the negative here, wag kayong mag-worry, no, kung bakit negative yung nakukuha yung value. The negative sign just means that it is working on the opposite direction, or yung vector niya, because essentially this is a vector, no? Yung vector niya is in the opposite direction as opposed to yung drawing natin. Okay? So you can just drop off the negative sign, no? So pwede natin i-drop lang to, so we have 228 kilonewtons. Okay? So when you have 228 kilonewtons, pwede nyo na i-multiply siya by 30 millimeter per second para makuha nyo yung final power niya, no? Okay? So, before we proceed to problem 3, are there any questions? Or meron bang clarifications kayong gusto? Or meron ba kayong observations?
Sir,
Yes, go ahead.
sadya po bang kapag pag-drawing, pag kinukuha po yung load, final area yung ginagamit. Tapos pag extrusion po,
Initial?
initial area.
Yes, yes, sadya yun. So again, kasi it's because of how slab analysis is done, no? So pagka always remember extrusion, initial yung minumultiply natin. Pagka drawing, final tayo nagwo-work.
Thank you po.
Okay. Sige. Other questions? Okay, so I think sana malinaw. And kung wala ng questions, can we proceed to the next problem? Kahit chat nyo lang K. Yes, thank you, thank you. Okay, thank you. Thank you everyone who responded. So proceed tayo sa last problem for today. Our last problem is uh whoop, whoop, PDF. Okay, to. So last problem natin is uh problem number three. So we are to determine the smallest wire diameter that can be cold drawn from a 15 millimeter wire through an orifice with a diangle of 30 degrees using a system with a maximum power rating of 4.5 kilowatts. So the drawing process proceeds at a rate of 125 millimeters per second. So this is relatively fast, no? And usually class, no, pag when we are doing drawing, no, mabilis to. So um, if you look at try to look at videos of drawing operations, no, sobrang bilis nung pag-coil and uncoil niya. So, and unfortunately dito sa ano no, department natin wala tayong drawing na equipment, no, so hindi natin ma-demonstrate. Pero and sa Pilipinas rare lang kasi na may drawing process tayo, no. So nakikita niyo lang to usually sa mga kasi nag-i-import lang kasi tayo ng drone wires, eh. So, pag try nyo lang i-check, it's very interesting, no? Sobrang bilis niya and actually it's a very parang hazardous na process, no? Kasi at any time pwede mag-snap yung wire and if the wire snaps, parang it could parang wick around, no? Pag nag-snap yung wire natin. Okay? So, eto pero just an interesting note, no? There was parang may attempt sana na magkaroon ng project which could have placed some ano no drawing equipment dito sa department pero parang hindi kasi nag-come into fruition siya, eh. Sayang kasi may experience niya sana siya. Okay? So eto meron daw tayong so what we are trying to look is the smallest wire diameter, no? And the orifice diangle is 30 degrees. Thus, given yung maximum power, no? So, this power rating will actually be a determining factor para makompute natin yung smallest wire diameter. Okay? So, let's do MS Math. Okay, so the first thing we need to do is, para makompute to, is compute muna natin yung drawing pressure needed para for you to actually cold draw this 15 millimeter wire. So again, ang convention class is pagka hindi sinabi kung ano yung 15 millimeters na yon, it is usually the diameter. Okay? If it's not stated, then it's a diameter na parameter or a diameter value. Okay? So we have first compute natin is si B muna, no? So that's B equals mu cot alpha. So mu natin is 0.3 according to the problem. Coefficient of friction is 0.3 multiplied by the cotangent ng the diangle was 30 degrees. So we use again half diangle lang. So we have 15 degrees. So we have 1.12 yung B natin. Okay? So if we use the okay, sorry. So ang sabi is Meron kasi tayong initial na given, no, na ang sabi sa given natin is meron tayong power requirement dapat 4.5 kilowatts siya. Okay? So kung 4.5 kilowatts to and we know that the power is just equal to yung force, so yung magiging drawing force niya multiplied by yung um yung yung drawing rate niya. Okay? So let's just say rate, no? Rate R. And given yung drawing rate R, ang sabi na sa problem is ang drawing rate R is actually 125 millimeters, no, per second. Then actually we can compute for the force needed to for this process to actually proceed. Tama? So if it's 4.5 kilowatt hour and I'll just do 4,500 para naka watts to, and if it's 4,500 divided by millimeters, you should get naka mega siya. Tama ba? Naka kilonewtons siya. Hindi, sige. Just to be sure, ang gagawin natin is 0.1255, no? Para naka meters to. So that's 1, 2, 3, tama. 0.1255. So if you compute it, then we should have a force equal to 3600 na newtons, which is 36 kilonewtons, no? So yun yung amount of force na, or this is the amount of force as specified by the power rating, given na we are to draw it at a 125 millimeters per second na rate. Okay? So, since given na to, yung 36 kilonewton, then we can just equate the 36 kilonewton. So, yung 36,000, pwede natin siya i-equate sa yung equation natin, sa drawing load na equation. Sabi daw the flow stress is 430. And since this is a wire, no? So if it's a wire, always pag wire kasi it means na yung cross-sectional area niya again is a circle or or circular siya. Therefore, kung circular siya, it is homogeneous yung deformation natin. So hindi na tayo mag-apply ng yung correction factor na 1.155 or yung 2 over square root of 3. So 430 lang diretso. 430. Yung B actually natin dito is greater than the fraction, no? So magiging 2.12 to plus over 1.12. Tama? Multiplied by 1 minus, this is drawing, therefore ang nasa taas is final diameter. Tama? So this is AF over A naught. Okay? Raised to the power of B, which B is equal to 1.12. Okay? So ito, if we want it to be in terms of diameter, pwede ang gawin natin is 2 times ganito tapos df over d naught siya. And df is actually what we are trying to, or what we are looking for, no? Kasi gusto natin yung smallest wire diameter na kaya ng system na to. Kasi actually, for 4.5 kilowatt, I mean, for 4.5 kilowatt at a rate of 125, pwede siya actually mag-go lower, no? So, or pwede siya actually na small lang yung yung change niya in the wire diameter, no? Pero kung gusto natin i-maximize to, then we want to compute for the smallest, kumbaga yung largest na reduction na kaya nating ma-produce given the settings na binigay sa atin. Okay? So, if we equate this with etong the maximum load, which is 36,000, then we are trying to get the smallest na diameter, which means the largest na reduction ratio or the largest reduction strain. Okay? So pwedeng, eto, let's just use D, no, para ma-compute natin siya. So D, tapos sa baba is the initial. So ang initial natin is, what is the initial? Initial is 15 millimeter wire siya. 15 millimeter. So okay lang na gamitin natin, naka-millimeters to kasi magka-cancel out lang kasi yung units, no? So anytime may ratio kayo class na okay lang na hindi nyo i-convert sa SI units, no? Kasi eventually magka-cancel out lang naman yon dahil naka-ratio siya. Okay? So that's, nasaan na to? Eto na siya. Multiply natin to by pi over 4, 13.1416 over 4, that's pi over 4 times, times 1416. Di ko kasi alam yung, alam ko meron din tong anong class, no? Pi values, pero di ko mahanap ngayon. So, I'll just use 13.1416 over, ano yun, sorry? PI? Okay, thank you. So, try ko. I-type ko lang PI, no? Okay, thank you. I did not know that. Thank you, ano, Rebo. So, medyo na-explore mo na pala to. That's good, no? So, that's pi over 4. Tapos, yung final diameter natin is D, no? Okay. Bakit siya nag-error? Okay, pi over 4D squared. Tama? Again, hindi 15 yung in-input natin dito kasi yung 15 is the initial. And again, pag extrusion, we are multiplying it by the final diameter. So, lahat ng numerator at yung dulo is final dimension siya. Okay? So, kaya siya ganyan. So, if we solve this right, 430. Ito this is megapascals, no? So, kung megapascals siya, tas minultiply mo sa millimeters should give you pascals. I'm just trying to look class, no, kung tama ba yung ano, yung units ko. So, megapascals multiplied by millimeters gives you newtons. So, kaya dapat 36,000 to. Okay. Mukhang okay to. So, maybe I can show you the final answer dito, no? If I press enter, it's taking too long daw. Hindi ko alam kung ba't nagte-take too long siya. No. Mhm. Kasi nade-detect niya na different si D. Ba't siya nag-end solve? Wait lang, class, isa lang naman yung pinapahanap ko. Same D lang naman to. I'll try to use a different variable class, no? Gawin kong X. Try ko lang kung yun ba yung reason kung bakit. Solve for X. Same lang. So the answer is 9.19. Pero my notes says 12 millimeters, no? So I'll have to double check this, no, kung bakit magkaiba. Wait lang, 430
Sir, feel ko po yung sa ratio, sir.
sa ratio.
Kasi
Ah,
parang meters po yung nasa labas na D. So, dapat yung sa ratio po, naka-meters din.
meters yung nasa labas. What do you mean? I'm sorry. Di ako
Yung
naka
D squared po.
D squared. Ito?
Opo. Di po ba meters siya?
Naka kasi kung millimeters to, magiging millimeter squared kasi siya, multiplied by megapascals gives you newtons. Tama? Yung left hand side natin naka newtons na eh. Naka 3600 siya eh. Okay. So, hindi ko quite sure class, no? Baka, can you calculate it on your own? Pwede ba kayo mag-calculate using normal calculator lang? Just try to check kung 9.19. Kasi according to my notes, it should be 12, no? Pero, I don't know kung bakit, ano. Trying to double check the values, no? Baka 2 times 1.12 pi over 4 x squared. 600. May nag-chat. Let me look at the chat, no? Wala po yung velocity. Na-incorporate na natin ano, kasi kinuha na kasi natin yung ano, 3600. From 4.5 kilowatts, dinivide natin by 125 para makuha natin yung 36. So, sige, maybe I can leave this to you guys, no? Or baka mali yung notes ko, posible din yon. So, basta this is how the process should look, no? So, just try to solve it, tapos i-ano nyo na lang class, no? Kung ano yung correct final answer. Yes?
Kinuha ko po sa calculus, sir. 12.05 po yung lumabas.
Yeah, that's the correct answer, no? 12.05. So, hindi ba mapagkatiwalaan tong MS Math? Meron siguro tayong I can't find the error, no, sa MS Math. Mukhang tama naman lahat ng in-input natin. 430. So, siguro, I may have done something wrong, class, no? So, just tell me kung ano yung, yung kung paano ko nilayout tong equation na to, no? Kung bakit siya nag-result ng 9.19. And again, according to my notes, is 12.05, no? So, try to explore yung nag-MS, gumagamit ng MS Math, no? Try to look into the MS Math and why baka nga may mali lang ako ginawa. So, with that, I think we can end the session early. Unless otherwise meron pa questions. Meron ba ba? Wala na po. Okay. Thank you, Riquel
Wala
and
na rin, sir.
Rebo. Okay, thank you, John. Yung mga girls natin, nandyan pa ba kayo? Geneva, Ivana?
Wala naman po, sir.
Okay, that's good.
Wala
Oh, okay, thank you, Geneva. Nawala si Nicole, no? Nakita ko siya kanina eh. Nagta-try to connect. Baka unstable yung internet niya. Okay, so thank you everyone for coming to this session and I'll see you next week. Next week, actually exam na pala, no? Exam week yon. Tapos magkakaroon na tayo ng yung second half ng lesson natin. By the way, class,
Sir,
we are, sorry,
sir,
go ahead.
next week pa po, sir. Kasi po dun sa syllabus natin,
Next,
23 to 26.
next, sorry, di ko chinek, no? Let me double check. Thank you for pointing that out, ano, no? Jan. Wait lang. Classroom. Oo nga, kasi deadline na pala ng, ano, no? Ng extrusion and drawing tomorrow or end of the week. By the way, pinanood nyo yung ano, class, Metal Cup? Or at least, ano ba kayo, interested doon? Would it be something you would be interested in? Kasi si Juan actually, yung TA natin, si Juan, isa siya sa nag-represent sa ano no, sa Philippines. Pumunta sila ng Russia sa Krasnoyarsk. Nakalimutan ko paano i-pronounce. Basta sa Russia sila pumunta. They were a team headed by or they were coached by Sir Carlo tsaka si Ma'am Joy. Tapos pumunta sila ng Russia and you can ask one, no? And I believe it was a good experience for them. And I think sa future baka meron sa inyo na that would want to create a team, no? Tapos pwede kayong sumali sa next Metal Cup kasi I believe they're trying to do this as an annual na event, no? So if you're interested, usually si Sir Carlo tsaka si Ma'am Joy yung ano no, yung parang team leaders nito. So if you're interested, I can submit your names, no. Wala pang exam. Oh, sorry. Before we proceed with that, the take-home exam should be released October 23. That's tomorrow. Tomorrow pala, sorry. Fake news yung next week. Tomorrow class, no? So again, for the record, tomorrow ang release date ng take-home exam natin. And it's due on October 26 and after October 26, actually pwede pa lang kasi 29 pa yung ano no. Tapos magkakaroon kasi ng reading break. Eto pala yung medyo ano class 'no, kasi magkakaroon ng reading break. So, as much as possible ayaw namin magbigay ng any modules during that time 'no. So, we may have to adjust some of the syllabus and let me just i-ano ko lang yung syllabus nating class 'no. Sorry. Okay. So, sa syllabus natin class, the reading break is scheduled November. Familiar ba kayo kailan 'yon? Or nakarating na ba sa inyo 'yon, yung balita about the reading break?
November 2 to 6 po ata.
2 to 6. Okay, so if it's 2 to 6, then it will overlap itong the first part, no? So, may chance class, no, na ano, shorten tong powder met tsaka metal joining natin. Kasi ang balak sana dito is ano, no, we invite our friends from the industry para magbigay sila ng a short webinar. So, maybe hindi natin magawa yun, no? And this will be just a simple module na lang siya. So, mukhang shorten natin tong part na to. Sorry. Ito pala yung part na to. Itong part na to. So, this is supposed to be meron tayong guest speakers, health, safety, and environmental consideration, pati yung process control and integration. These are actually new topics class, no? Traditionally, hindi to kasama sa MetE, back then it was 147, no? Pero sa inyo 177 siya. Back then, hindi kasama yung HSE tsaka process control and integration. So, I may perhaps just give this as a ano, no, magbibigay lang ako ng a few readings, a few online materials that you can read. Pero in general, hindi naman to kasama sa exam. This is more supplemental lang siya, kumbaga. And mukhang dahil sa restriction in time, no, mukhang tatanggalin natin tong yung webinar with a guest speaker. Okay? Tapos, isa sa, hindi pa to final class, no? Pero, isa sa nakita namin ni Sir Jolo kasi we've noticed na, yun nga, sobrang stress ng mga students ngayon, no? Kasi, sa dami ng requirements, lalo na kasi it is all new to us, no? So, there are certain subjects na sobrang daming requirements and we want to help you guys na i-lessen yung requirements. So, isa sa naisip namin, initially pa lang to, pero hindi pa siya final, no? Instead of doing two design problems, baka bawasan na lang namin. Gawin namin siyang one design problem na lang. Tapos, it's your choice kung ano yung gusto nyo. Kung would you want to do the deformation processing track or pwede rin yung foundry na science track. So, depending on which you are more comfortable with. No? So, hindi pa siya final class, no? Pero yun yung isa sa naisip namin para mabawasan yung or ma-tone down yung requirements for this course. Okay? So, with that, meron pa bang questions? By the way, as early as now class, no? Pwede sigurong you can siguro work among yourselves etong sa yung webinar natin. So, just try to uh, coordinate with the other class, no? Kasi this is the whole MetE177 batch. Kahit wala pang topics, no? Kasi i-assign kasi yung ano nyo, yung type of casting lang naman to. So, hindi pa ina-assign yung kung sino yung magkaka-group. Hindi pa na-assign yung topics, pero gusto ko sana na as early as now mag-usap na kayo kung how you plan to deliver this webinar, no? So, kung Zumba, kung paano yung setup nyo, is it parang kung sa Zoom, kung naka-seminar mode ba siya or anong tawag dito? Naka-webinar mode or parang conference mode. Yung mga ganong technicality siguro. As early as now, okay lang ba na pag-usapan nyo na siya? Or kung Meet, yung Google Meet yung gagamitin nyo, try to look at the features of Google Meet. Tapos, if it fits the needs of your simple webinar. Again, this does not have to be, something na yung bonggang-bongga siya. It's a simple webinar. We may invite other faculty members to join the webinar, no? Pero definitely kami ni Sir Jolo nandun kami. Tapos we can invite yung younger batches, those taking MetE177, pwede namin silang invite para makinig sa inyo yung simple webinar na to. And yun lang siguro. Okay ba tayo doon? Pwede bang mag-assign ako ng parang class president? May binolunteer si Rebo. Okay lang? Or kayong dalawa na lang, si Rebo and Riquel, or bang co-class presidents kayo? So I'll assign you guys as co-class presidents. Try to coordinate with the other class. Tapos tingnan nyo kung paano nyo ma-deliver tong yung webinar na to. And try to think of a presentation date, no? Yung parang feel nyo okay na date for you guys to present hopefully before tayong mag-exam class, no? So hopefully nakapag-present na kayo bago mag-take home exam number 2. Sana. So try nyo mag-set up ng date na rin. Okay? Okay tayo doon? So thank you again, Riquel and Rebo, for volunteering yourselves, no? Okay? So siguro yun lang ang major concerns for today. And hopefully ready na kayo sa exam, no? Di ko alam kung gaano kahirap yung exam. Pero sana kakayanin nyo naman since take home exam siya. Okay? So thank you for coming today, class, and I'll see you next week na siguro. Tama ba? After exam. Mukhang next week na yung kitaan natin. Pero I'll make an announcement kung ano yung meeting dates natin. Okay? Thank you, everyone. And
Sir,
okay. Happy lunch. Paano